In this example, we're going to perform the indicated operations and we're instructed to enter D and E if the answer does not exist. So notice for all of these problems, it looks like a lot of them involve 1, dividing or multiplying by 1 or 0, okay? Or we have the number and its opposite or the number and itself related. So all of these are going to be pretty easy problems to do because we have some nice properties involving multiplication and division and the numbers 1 and 0. So rather than just state those properties and use them to apply it, let's think of these based on the idea of how we talked about division and multiplication. So this first problem, we have 3 over 1. And remember, we could think of a fraction as division. So this is equivalent to 3 divided by 1. So in copies of language, or groups, how many groups of 1 are in 3? Well, there's 3 ones in 3, so our result is going to be 3. So 3 divided by 1 is 3. Let's look at the next one. Now we have negative 3 over 1. In division language, we would say negative 3 divided by 1. And we could say how many groups of negative 1 are in 3. And we discussed this with integer chips, but you may want to think of this in terms of using what we know about signs when we're dividing. Okay, so we could think of dividing 3 by 1, and we would get 3. And when we're dividing, when one number is negative and one is positive, that means the answer is negative. So notice when we divide negative 3 by 1, we get negative 3. And this is a general true result for any number. If you divide any number by 1, you get back the number itself. Okay, so you don't need to memorize that rule. Once you do it a few times, you get to see the pattern. But that's a nice fact we can use. Now we have negative 3 over negative 3, which we can rewrite as negative 3 divided by negative 3. Okay, so we're dividing a number by itself. So how many groups of negative 3 are in negative 3? Well, since the numbers are equal, there's one group of negative 3 in negative 3. Okay. So we could also think of this as ignore the signs, use the absolute values. 3 divided by 3 is 1. Since both of the numbers are negative, your result is positive. Let's look at the next one. This is multiplication. So we have the opposite of negative 3 times 0. Okay. Now, we can simplify the opposite of negative 3 first. We don't really need to, but the opposite of negative 3 is positive 3. Okay, and we could think of this as 3 groups of 0. Okay, or in terms of repeated addition, add 0 to itself 3 times. Well, the result is going to be 0. So in general, when you multiply a number by 0, your result is going to be 0, whether it's the first number or the second number. Now we have the next one. So here we have this number on the outside, so we may want to call this the opposite of 3 divided by negative 1. Okay, and there's rules that we can apply here too, but let's try to just think this through. So for the opposite, I'm going to put that on the outside and divide 3 by negative 1. Okay, well, we've already found 3 divided by negative 1. That's negative 3. So we have the opposite of negative 3, which is 3. Okay, so now let's look at some patterns, because that was a little bit tedious. Let's write something right here. So when you have something written in fraction form, okay, no matter where the negatives are, so here we had a negative on top and negative on bottom, we could just cancel those out, and lots of times we cancel them out by making them look like plus signs. Okay, so any two negatives will cancel each other out to make a positive, because a negative divided by a negative is positive. And even though this is written as an opposite on the outside, it has the same effect. These two can be canceled. Then we have 3 divided by 1, which is just 3. Now let's look at the next one. Negative 3 divided by 0. Okay, now it may be tempting to say this is 0. We saw that when we multiplied by 0, we got 0. But let's write this out in words, what this means. It means how many groups of 0 are in negative 3. Okay, so in terms of addition, okay, we can think of, we want to add up, how many zeros would we have to add up to get the result of negative 3? Well, I can add up zeros forever. I will never ever get to negative 3. We'll always be stuck at 0. Okay, and so frequently we say that dividing by 0 is undefined or indeterminate, or what we're going to enter is this DNE for the answer does not exist. Okay, now remember, you can divide 0 by a non-zero number, which we'll see in another problem or two, but you can't divide by 0. Okay, so just to see this in one other way, if it was written negative 3 divided by 0, okay, when the divisor is 0, that's when we have a result that the answer does not exist. Let's look at the next one. We have negative 3 over 3, or equivalently, negative 3 divided by 3. Okay. So we can think how many groups of 3 are in negative 3. Okay, or we can use some of our integer rules and divide their absolute values. 3 divided by 3 is 1. We have one negative number and one positive, so the result is negative, and our answer here is negative 1. So a number divided by its opposite is negative 1. Next we have 3 divided by negative 3. And notice here, it's the same numbers, just in different places. 3 divided by negative 3, but we'll have the same result. So when you divide 3 by 3, you get 1. Since one of the numbers is negative, the result is negative. Okay, and we could do this in more depth with integer chips. Feel free to do this if you want. Now we're just looking at some general patterns. Okay, we're going to need a new page of slides. If you need to reference this, you can rewind the video. In this example, we have the opposite of 3 over negative 3. Okay, so we could think of this as the opposite of 3 divided by negative 3. Well, we saw in the last problem that 3 divided by negative 3 is negative 1. So we'd have the opposite of negative 1, which is positive 1. Okay, now notice a rule that we used in this problem back here. When you have an opposite of a negative and a negative, when you have two negative signs, remember a negative times a negative or a negative divided by negative is a positive. So two negative signs will cancel each other out. So you can feel free to do that. Okay. And we will end up with positive 1, and the final answer is over there. Next, we have the opposite of 3 divided by 0. I'm sorry, of 0 divided by 3. Okay, so we can think of this as the opposite of 0 divided by 3. Well, how many groups of 3 are in 0? Okay, well, there's 0 groups of 3 in 0. So we can have the opposite of 0, and in general it's not wrong to write opposite of 0 or negative 0, but we think of 0 as not having a sign, and we just write it as 0 without a positive or a negative sign. So our result is 0. So 0 divided by any non-zero number will always be 0, okay? And the signs of the numbers won't matter because the sign of 0 doesn't matter either. We don't think of it as positive or negative. Now we have negative 3 times negative 1. Well, we already saw to multiply two numbers, multiply their absolute values. 3 times 1 is 3, and the product of two negatives is positive. And again, if you'd like, when you see two negatives, they cancel out, making these positive signs, and our result is positive. Just make sure that you don't confuse this with an addition symbol. That's a sign of a number. And finally, 0 times 3, so 0 groups of 3. Well, 0 groups of 3 is going to be 0. Okay, so there's some nice results here, and I would suggest practicing with these 1 or 2 times so you can start to see the patterns more quickly. Problems like this will come up a lot, and it's good if you can compute them quickly.